So once again, good evening to everyone. I hope everyone's doing well. I'm so sorry that I've had to have this session right before a long weekend, but it was initially planned for tomorrow, and then I decided to change it to today so that anyone who had plans for tomorrow didn't have to worry about attending this. But it is recorded anyway, so people can catch up with it at any point in time. And then, as I had mentioned in my email, if you do experience issues with connectivity or once you try to connect, if you get kicked off, if you try to connect again to the collab session and it doesn't allow you in, please don't be alarmed because there are currently several issues with Blackboard. It's a global problem. So we've had several issues over the past couple of days, and I'm sure you've probably seen with some of your assignments, the deadlines were extended because of those issues. So please don't be alarmed. I will continue as long as I am also on the session, and it is recorded, as I said, so you can catch up with it if you do get kicked off and aren't able to join again for any reason. So let's go ahead and get started. I have projected the assignment. As you will see, it is same idea as assignment one in the sense that it is worth 100 marks, and then pretty much the same setup where you can handwrite if you'd like to. That's perfectly fine. If you want to type it out, you can as well, as long as you ensure that either way, whether it's a Word document or a handwritten assignment, you are converting it to a PDF document. I know that because of the content in this assignment, a lot of the students do prefer to handwrite it just simply because some of the equations are a bit tough and it's also time consuming to type them up on Word. So if you are happy with writing it out, that's perfectly fine, no stress at all. And just ensure that you do upload it as a PDF document. So I will look at any questions that you do have in the chat. You can type that into the chat. Or if you do want to speak as well, that's perfectly fine. You can just press the raise your hand icon. And as we go along, you can just let me know if there's anything you need clarification on. One important thing that I am going to discuss is the bottom of this assignment. So point 7, 8, and 9 is indicating to you that in the assignment there are two sections, A and B, and you are going to answer all of the questions in section A. In section B, you're going to select one of the questions, not both of them. I'm not sure if you've all been made aware of that or if you've read it in your assignment. I know that obviously you're used to answering all questions in an assignment, but this year for stats, the structure has changed. So in case you didn't read that instruction on the cover page, please make sure that you ensure that for section B, you are only answering one of the questions, not both. So section A is based on learning units 4 and 5. Those are both compulsory questions, so you do have to do both of them in section A. And then in section B, you have learning unit 3, which is split up into your grouped and ungrouped data. And you're going to select one of the questions only from here. It is whichever you prefer, so you can naturally go with whichever you find easier or whichever you are more comfortable with and you feel like you have a better understanding of. So it's entirely up to you. But I will just go through it and I'll give you an idea of where your marks are allocated, how to go about answering a particular question, what's required in terms of mark allocation. So, for instance, with a particular question, you naturally need to know what's necessary to include when showing a working out. Are you just showing a final answer? If you're using a calculator method, where your method marks are, that kind of thing. So let's go ahead and get started. And you'll see that here there's not much theory. There's not many theory questions as opposed to assignment 1, which had pretty much most of it was theory. So here it's mainly application based. You have mostly calculations that are required, and the only time that you're really looking at explanations or any theory actually is where you have an explanation or an interpretation of a specific calculation. So it says to you at the top here, and again, I don't know if all of you have been able to identify that or have read through the fact that they said to you in section A, you are answering both questions 1 and 2. And then, as we said in section B, you'll see that they have indicated to you that you will only be answering one out of these questions. So here it is here for section B, answer question 3 or question 4, but not both of them. So let's go back to the initial page. So here, question 1 is for 30 marks. And they said to you that the table below indicates the number of years of experience. So I just want to highlight as we're going along. So it indicates the number of years of experience of a sample of salespeople who work for Hornbill Pty and their corresponding sales in thousands of rands over the last 2 weeks. So here they have given you a table with information indicating to you that the years of experience is your X variable and the sales is your Y variable. And remember, your sales is in thousands of rands. So they've given you 6 values here, and that's from the fact that they listed out 6 values. So immediately here, n is equal to 6, which is your sample size. It's the total number of values that were provided to you. And then they said to you in question 1, by completing the table below and then applying the relevant formula, determine the line of best fit for the bivariate data set. Do not change the units for the variables, and no marks will be awarded if the table is not complete. So you then need to copy this table that you see here, and you're going to redraw it in your answer booklet. As you can see, we have the X variable in the first column, the Y variable in the second column. The X variable is the one up here, so you're just going to enter the values for X. And then the Y variable is here, so it's just going to be the values for Y. So those two were given to you already, X and Y. So you'll just list them out here, going down. Here is Y. Then you have the columns X squared and XY. So all you're going to do here, literal to the words X squared and XY, or the variables rather, X squared and XY, you're going to, for the X squared column, you're going to square X, square your X variable. And I'm just going to do the first set of values for you. So going this way, I'm going to do the first ones here. So I'm going to go across there for you and just do the first one so that you're comfortable with how the rest of them will pan out. So remember, for the X variables, you're basically taking all of these and listing out 11, 8, 3, 4, 5, 4, and the same with your Y. It was 130, then 95, and so on. So for your column X squared, you're literally just taking the X value and squaring it. So the first X value is 11. So that would be 11 squared, and 11 squared is 121. So it's as simple as that for the first one. And you'll do the same for all of them, meaning that for all of them, you're going to simply take the X value and square it. Then the next column, which says xy, is you simply taking the x value and multiplying it by the respective y value. So here's x for the first one, here's y. So basically in line with it, you're taking x, multiplying it by its respective y. So 11 times 130 gives you 1,430. And you're going to continue doing that for each one of them. So the next x times y, then x times y, x times y, and so on. So you would then complete that table, and then once you're done with the table, all you're going to do is you're going to total. As you can see at the bottom here, it says total. So in terms of your total, you're going to basically add up everything in that column. So all the x values that are listed out, which would be all of these, you'll put the sum of it here. It's called the sum of x. Then you'll sum up all the y values, which are all these ones here. It will be the sum of y. Then all the y values, which are all these ones here, it will be the sum of y. Then all the x squared values that are listed out here will be the sum of x squared. All the xy values here will be the sum of xy. So you're simply going to put in the total for each column. Let me just have a look at the question. You'll just leave it as 130. You are allowed to do that whenever it is in hundreds of thousands or in thousands or in millions. If the figure is too large, you're allowed to just leave it as is, as you can see in this question. But when you are answering questions specific to changing it, which I'll show you just now, then you'll need to just change your final answer. Okay, so in the table, you can leave it exactly as it is. As I said, you'll put in the 130, 95, 35, 65, and so on. So now that you have the sum of each of them, the sum of x, the sum of y, the sum of x squared, the sum of xy, you can look at what this question asked you. So the question had said to you, complete the table. That was the first thing. And then your marks naturally will obviously come from that. You would get quite a high mark. So of this 15 marks, I think it's about half of it or so, or just over half of it that's allocated to just the table. Okay, so naturally it's quite a big portion of your mark allocation. So please make sure, and they did stress it here, that there will be no marks that will be awarded if the table is not complete. So you definitely need to show the working out. Oh, sorry, not the working out. You need to show the table itself. So with all of the values, like I was showing you just now. So then they said to you, then apply the relevant formula and determine the line of best fit for this bivariate data set. So what they mean in terms of the line of best fit is they want you to determine the value of the formula of y is equal to, it's either a plus bx, or you can write it out as y is equal to b1 plus b0x. Okay, so here you're going to, and the formulas for this are in the formula sheet. I just want to show you at the end. You'll see that there is a formula sheet in the assignment as well as in your textbook as well. There is also a formula sheet at the back of your textbook. I'm not sure if you know that, or if you've been able to have a look at that at the end of your textbook. So the formulas for it are here. Okay, so you have the y is equal, actually, I think I swapped the two around. So it's y is equal to a plus bx, or it's y is equal to b0 plus b1x. So you can just pull that through there. I think for the first one, I just swapped them around here. So that would be b0 first. Okay, so here it's b0 plus b1x. Either one is fine. They both mean exactly the same thing. Normally, we just stick to using a and b in the formula. So in the formula, you're actually calculating the value of a and the value of b. So in the formula for a and b, you always calculate b first and then you calculate a. This is because the value of b is used to calculate the value of a. So the formula for b, you will see in the formula sheet as well, is n multiplied by the sum of xy minus the sum of x times the sum of y over n times the sum of x squared minus the sum of x then squared. So n here, you already know. Please make use of brackets when you're putting this into your calculator. So it'll be n times, because it is no sign between the variables. It's a given that it's multiplication. So it'll be n times your sum of x, y is already calculated here. So once you draw up the table, you will just pull your value through from there. Then it is minus the sum of x times the sum of y. Again, no sign between the variables, means it's multiplication. So here's your sum of x, here's also your sum of y. You're multiplying the two. Again, make use of your brackets. Then you have n multiplied by the sum of x squared. So n, again within brackets, n multiplied by your sum of x squared is here, and then it's minus the sum of x within brackets, which is this figure here, the first column, minus that value squared. So here you'll close your bracket, and then it's minus whatever the sum of x is squared. Once you have that value for b, you're then going to use that in your calculation of a. So a is equal to the sum of y minus b times the sum of x over n. So the sum of y, again here in your table, the last value, your total, that's the first part. B would have already been calculated here at the top. It's two decimal places unless they state otherwise. And then the sum of x here is also here in the first column. This is, remember, b times the sum of x. And then it's n in your denominator, which we already said is 6. So once you have that value for A and B, all you're going to do is substitute that into the formula y is equal to A plus bx. Please don't be alarmed if you ever get, not just specific to this example, in any example, if you ever get negative values for both A and B, that's perfectly normal. It is acceptable. We do often get negative numbers for them. So please don't think that your answer is incorrect. It's perfectly normal to get that. So that is your first question. The second question said to you to estimate the sales in thousands of rands that would have been produced in the last 2 weeks by a salesperson who has 7 years of experience. So once you calculate in step 1 the line of best fit for the bivariate data set, you would have had in this formula the values for A and B. So I'm just going to give you random values for this formula to show you how to answer question 1.2. Let's just hypothetically say that y was equal to 12 plus 1.95 and then x. So you have a value plus 1.95 and then x. So you have a value for A, you have a value for B in the formula. And when they say to you, estimate what the sales would be for a person who has 7 years of experience, the years of experience is your x variable. So in place of x in the formula, all you're going to do is you're going to replace this value of x with 7 because this is the number of years of experience. So it'll read y is equal to 12 plus, and make use of your brackets here, 1.95. There's no sign, so it's a given that it's multiplication, and it'll be times 7. For example, whatever answer you get, because they asked you for the sales in thousands of rands, you will multiply that by 1,000 to give you the answer as a thousands of rand figure. So whatever you get there, it'll be times 1,000. So let me just calculate this for you, just to show you how this would work out. So this would have been 25.65. This answer here, actually, let me just write that there. Let me remove the question mark. Okay, so this would have been 25.65, but they asked you to indicate your answer as a thousands of rand figure. So you'll multiply it by 1,000 and your answer would be 25,650. And that would be your final answer. Okay, so that is question 1.2. And then question 1.3 then asked you to use your calculator and calculate the coefficient of correlation for the data set. So using your calculator for the coefficient of correlation, you're going to change the mode on your calculator. It's on the top right-hand corner where it says sorry, next to the on button, it says mode. So you'll change your mode to stats mode. It will say stats. Then you'll choose the option that says A plus BX. I think it should be option 2 on most calculators. Once you have pressed that, it'll give you on your calculator 2 columns, X and Y. In the X column, you're going to type in all of your X values. So you'll type in 11 and press the enter button or the equal button. Then 8 equal, 3 equal, 4 equals, 5 equal, and then 4 equal. You'll basically enter everything. Then you'll use the right arrow to navigate to the next column and you'll go all the way to the top. So here your y values were also given. It was 130 equals 95 equals 35 equals 65 equals 25 equals 85 equals. Once you're done with entering all of the values, you're then going to press the AC button. It's one of the green buttons on your calculator. It's above the division sign. And then you're going to press Shift and the number 1. Remember, Shift is the option second F on your calculator on the top left-hand corner. So you'll press Shift and the number 1, and you'll choose the option that says REG for regression. And then here you'll see that R is, I think it's option number 3, if I'm not mistaken. This is the coefficient of correlation. So you'll press number 3 and equal to, and that will give you your value for R. Then they ask you to interpret your answer. When you interpret your answer, you need to have a look at your textbook of how this is interpreted. You will either say that the value is strong or weak, or you'll say that you'll say that it's positive or negative. So there's always two things you need to say when you're interpreting R. You need to say that it's either strong and positive or strong and negative, or you can say it's weak and positive or weak and negative. So it will always be one of the two under each of these categories. It'll either be strong or weak, and it'll either be positive or negative. So here generally, because a coefficient of correlation can be between equal to -1 and 1, then you can have anything as your answer between -1 and a positive 1. And you'll see that the closer it is to 1 rather than 0, the stronger it is, the closer it is to -1. Again, the stronger it is. But obviously, it depends on whether the value is positive or negative, and that will indicate to you whether it is a strong or weak, or whether it's a positive or negative relationship. Okay, so that is your R value and how to interpret it. Then you have in the last question your coefficient of determination for the data set and interpret your answer. So the coefficient of determination is calculated as r squared. So you'll simply take your answer from 1.3 and you will square it and you will make that answer a percentage. So whatever answer you get when you square r, make sure that you convert that to a percentage. And when you interpret your answer is interpreted by saying that when the x variable, which is the years of experience, changes, then your y variable, which is your sales, will, sorry, let me write that down for you. So basically, when you are explaining the r squared value, your coefficient of determination, it's basically saying to you as a percentage that any variation in y is explained by x. So here you're going to say that the change in x explains, or the change in x explains, or the change in the years of experience explains, and whatever you had as your percentage, you'll put it in here. It explains so many percentage or so much of the percentage of the reason or of the changes in sales. So if you get an answer of, and I'm just again here hypothetically speaking, so if you calculate r squared and it's just say 64%, for example, it means that the change in the years of experience, which is X, explains 64% of the changes in sales. And remember, it's because the relationship works in that way where X affects Y, but Y does not affect X. So basically, any change in X will explain the Y variable changing. So here we're saying that the change in the years of experience, the change in the years of experience explains 64% of the changes in sales. So that is question one. Any questions there so far? Okay, so let's look at question two. They did say to you very importantly here at the top that all final probability answers in question two should be given as a percentage to two decimal places, unless stated otherwise. So you need it to be a percentage to two decimal places. The first question said to you that a bag contains 9 green and 11 blue marbles. Now I'm going to just change those figures so I can show you how to calculate something like this, or how to draw up something like this. And I'm going to make it, just for the purpose of me showing you how to do this, I'm going to make it 5 green and 7 blue. So remember, you don't need to change this for your assignment. I'm just changing it so I can explain to you how to do a question like this. 5 green and 7 blue marbles. You are asked to select 2 marbles from the bag, but the first one that's selected will not be placed back into the bag. The first question said construct a probability tree to indicate the various possible outcomes and their probabilities. And they said to you, leave it as a fraction within brackets. And then they said to you, what is the probability that the two selected marbles will be of the same color? So let's start with the drawing up of the probability tree as per question one and calculating the various possible outcomes. So here, if we're saying that, and again, just for this example, if 5 of them are green and 7 of them are blue, then when you draw this up, firstly, there are 12 in total. That's the 5 plus the 7. So in total, you have 12 marbles to select from. So when you draw this up, you're going to say, and I'm going to draw it up at the bottom here, you're going to say that the possibility the first time around, and I'm going to say here first marble. So with the first marble, there is two possible outcomes. So the two possible outcomes is that you will land on green, or you will select green, or you will select blue. They said to you five of them are green. So you will say 5 out of the 12 are green. 7 of the 12 are blue. So 7 out of 12 are blue. Then the next part is now looking at the second time around what will happen, because they said to you you're selecting two marbles. Now the second time around, and this is a general rule when it comes to probabilities, it's based on the independent rule. They should have said that to you here, but it is something that's in your textbook that you should be aware of, that your probability trees are based on the independent rule. And the idea here is that with an independent rule, what happens the first time around has nothing to do with what happens the second time around. So here, with the second marble, they're basically saying to you that if you had selected green the first time, then you can still choose green again the second time, or you can select blue. The same if you had selected blue the first time, then what happens the second time around has no impact or will not affect or is not affected by what happens the second time around. So here you will find that the total outcomes at the end is that if it was green the first time, it can still be green or blue the second time. If it was blue the first time, it can still be green or blue the second time. Then they said to you that the first marble selected will not be selected, will not be placed back into, I'm just trying to highlight, will not be placed back into the bag. So basically, instead of having 12 marbles, you now are having one less. So that's 11. So your denominator for all of these then becomes 11. Now you're going to look at each one of them in isolation. So the first part you're going to look at is this at the top. So I'm just going to put a line through here to separate it. So the first thing is, I just want to change the color of this pen. The first option is that it was green the first time and then it was green again the second time. So you would write out the probability of it being green and green again. You would write out the probability of it being green and green again is going to be, and they ask you to leave your answer as a fraction. Here in the question to leave it as a fraction. So this is going to be 5/12 times. And again, because they said to you that it is the independent rule. The independent rule says to you that the probability of A and B is calculated as the probability of the first event, A, times the probability of the second event, which is B. So it's a probability of A times the probability of B. So here, your probability of A is basically the same here as the value of G. So it is 5/12 multiplied by, because of the multiplication rule, it's multiplied by your, oh, sorry, I didn't actually write down the values. Let me backtrack there a bit. So here, I thought I wrote those down. So here for the second part, where you have the second marble. So you're going to look at them in isolation. So I had written down here, if you look at, I put in this value, sorry, this highlighted part here, and we said look at the first part only, which is everything at the top here, and then we look at the second part. So what this first part is saying to you is because these two events are independent, what happens the first time has no impact on what happens the second time around. So the first time, and please pay careful attention to this, if the first time a person had selected green, and the second time they're selecting green again, then if the first time there was 5 green to choose from and a person selected 1 green, that left only 4 green to select from. So that becomes your numerator for the option for green again. Then the second part of it here at the bottom is if a person selected green the first time, so that was 5 green, that means that the blue had remained as is. It was still 7 blue, so that would be your numerator here. So as you can see, if a person selected green the first time and they did not place the marble back into the bag, then from 5 green, it went to 1 less, which was 4 green. So now there's only 4 green to select from because 1 green was selected the first time and it was not placed back. Then for the bottom part here, the one I'm circling, for blue, if a person selected green first, then it had no impact on how many blue were available the second time around because they chose green first. The blue would have stayed the same as it originally was. It was not touched at all. So it would still be at that 7 that it started off with. Now at the bottom here, so where I'm putting this curly brackets, this is now the opposite way around. So here you have initially starting off with 7 blue. So this is at first. Then when they selected, if they selected blue first, then the second time around, instead of having 7 blue, it now reduced to 6 blue. Because they selected 1 blue the first time, they didn't place it back in the bag, so it was now 6 blue that had remained. Then here, if they selected blue the first time, that means that the green would not have been touched. So the green will stay at its original 5/11. So this is how you would draw up a probability tree. As you can see, it's isolating each one and looking at if we select blue first and we then the second time around can either select green or blue again. If we selected blue the first time, then that means there's less blue to choose from the second time around. So it reduces your numerator because you now have 1 less blue to choose from. And then if you chose blue the first time, sorry, if you choose, yes, if you choose blue the first time and the second time around you choose green, then again here, and remember, sorry, just, okay, so remember it is exactly as you have it at the bottom. Let me just make some space here so I can write. Okay, so like I was saying here, green and blue. So if you selected, I think it was 5 green out of the 12 and 7 out of the 12 were blue, then whatever happens the first time has no impact on what happens the second time. So if you selected green first, you can still select green or blue the second time. And if you selected blue first, you can still select green or blue the second time. If you separate them, as I said, and you look at only the top half first, then all you're saying is if you selected green first, and then let me just change this. So here, they said to you that if you select a marble the first time, you don't place it back in the bag. So from having 12 marbles, once you select the first one, it removes that one and you're now left with only 11. So here you have 11 as your denominator for the second marble. So I'm going to say here second, and that was the first. So if you selected green first and you had 5 green, that means that when you select again, you now only have 4 green to select from. And if you selected green first, the blue was not affected at all, so it would remain as the original 7 over now 11. At all, so it would remain as the original 7 over now 11. Then it's the opposite for the bottom half now. So for the bottom half, if you had 7 blue and you chose 1 blue the first time, then you remove that 1 blue and there's now only 6 blue remaining. So when you choose the second time, you only have 6 blue to choose from. And if you chose blue the first time, the green the second time would not have been affected at all. So it would have been the original 5 that you had to choose from. It basically means that if you choose blue first, then all 5 of the green ones are still there. Only the blue had decreased by 1. So this is how you would draw up your probability tree for this one. No stress at all. I will definitely. Okay, so this is how you draw up your probability tree here. And then I'm just going to go back here to the one I originally had. Oh no, it got deleted. Gosh, okay. Let me draw that again. Let me just have a look at the question. No. You don't need to show the calculations. You'll just draw the tree. So I'm just going to draw that again because I mistakenly had removed it and then everything got deleted. So once you've drawn up this tree, you're going to find that you do need to go one step further and calculate the outcomes. So this is what I was explaining to you in terms of the independent rule. So the independent rule says to you that the probability of A and B occurring is calculated as the probability of the first event, A, times the probability of the second event, which is B. So you will need to apply that to your calculations for probability tree. You're going to say that the first thing that could have happened was that you would have chosen green and then green again. So you'll say the probability of green and green. And because they asked you to leave it as fractions, you will say that is 5 over 12 times 4 over 11. And that would have given you 5 over 33. Then the next thing that could have happened was, and I'm just going to do this in a different color so you can see that, it would have been that you selected green first and then blue. So here it would be the probability of green and then blue. So that would be 5 over 12 times 7 over 11. So that would be 35 over 132. Then the next thing that could happen, and again, I'm just going to do that in a different color, is that you would have had blue first and then green. So that's a probability of blue and then green, and that is 7 over 12 times 5 over 11, and that is 35 over 132 as well. And then the last thing that could have happened is you would have had blue first and then blue again. So that's a probability of blue and blue. So 7 over 12 times 6 over 11. And that is 7 over 22. And that then would be question 1. So that is the first question here for 7 marks. Question 2 said, what is the probability that the two selected marbles will be the same color? So again, if we use that same question in our answer, in our question, they want to know what's the chance it will be the same color. You're going to just look at this column here where it says G and G, G and B, B and G, and so on. And with this column here where it says G and G, G and B, B and G, and so on. And wherever it has the same letter, where it's the same color, like this, and here the last one, that first one was green and green, the last one was blue and blue, you're simply going to add their final answers. So you'll say that the probability is going to be green plus green and green plus the probability of blue and blue. So that would be 5 over 33 plus 7 over 22. And your final answer here would be 31 over 66. This you can convert to a decimal now. It'll be 0.469, which as a percentage is 46.9%. The reason I'm converting this to a percentage is because now you need to answer that final question. So you would say then the answer was 46.9%. You would say that there is a 46.9% probability that the two selected marbles will be the same color. And that would be it for that question. Okay, so that's question 2.1 done. Let's look at question 2.2. How would we structure this in the assignment as you have explained above? No. You'll do it exactly as you can see here, exactly as it is where the outcomes are right next to it on the right-hand side. And the answer, only this part here at the bottom, this here, where I've put in the little block, that can go below the diagram. Okay, so let's look at question 2.2. So there's not much that I can really help you, I can really tell you here because I'll be giving you the answer. But what I can help you identify here is the rule that will be used. So here, they said to you that the following contingency table gives the results of a sample survey of South African male and female respondents with regards to their preferred brand of cell phone. So they've given you the brand at the top, that's Apple, Samsung, Vivo, and then they've given you the gender in that first column, male or female. So here then you are looking at that last value in the last block, which tells you your total sample size. That's 450 people that they have interviewed. And the first question said to you, what is the probability of randomly selecting a respondent from the sample who prefers Vivo? So they only are asking you about one variable, about a person who prefers Vivo. So your answer here is based on your marginal probabilities. Your marginal probabilities are saying to you that you're looking at one variable at a time, and your answers can either be found in that total column or the total row. Basically, it can be any one of the answers from here or here. Sorry, not that last one. So your answer will be any one of these or the ones going across at the bottom, and it'll be that value over your total sample size. It's basically the formula R over N. So this is a marginal probability. The next one says to you, what is the probability of randomly selecting a respondent from the of randomly selecting a respondent from the sample who is not female. So here the wording that says not female, this says to you immediately when they use the word not that it is the complementary rule. So the moment you see the word not, it's the complementary rule. And the complementary rule says that the probability of an event not occurring is calculated as 1 minus the opposite, which would be the probability that the event does occur. So here you would say the probability of not female is 1 minus the opposite, that it is female. And then you can calculate that. Then the next one is what is the probability of randomly selecting a respondent who is female and prefers Samsung. So this is a joint probability. And in your table, a joint probability is where they are explaining to you two variables at a time. The joint probability in the table is, and I'm going to highlight it for you, it's everything that is within this block here. So it's not the totals here and here. It's only everything within that block. So all you're going to do is go to female, Samsung, and it'll be that over N. Then you have the next one, which says, what is the probability of selecting a respondent who is male given that they prefer Apple? So here, the moment you see the word given, it says to you that this is a conditional probability. A conditional probability means that the given one becomes your denominator. So the probability of a person preferring Apple will become your denominator. And the numerator will be a person who is male and who prefers Apple. So whenever you see the word given in a calculation, it is always going to be a smaller sample size. It means instead of looking at all 450 people, you now are only looking at the ones who prefer Apple. It's reducing your sample size. It's basically saying to you, instead of everyone, we can focus on only the ones that prefer Apple, and then your numerator is male and Apple. Okay, so that is the question based on your two-way contingency table. Then here at the top, it says to you, the probability that a randomly selected employee of company Y is female is 0.6. The probability that an employee of the same employee of company Y is female is 0.6. The probability that an employee of the same company works in the marketing department, given that the employee is female, is 0.2. What is the probability that a randomly selected employee of the company will be female and will work in the marketing department? So this is just manipulating that conditional formula. And it says the probability of A and B occurring is calculated as the probability of A given B, which they did give to you, is multiplied by the probability of B, which they also did give to you here. So all you're doing is multiplying, and that would give you your answer. Remember to interpret using a percentage. Just take your percentage and put it into that question and let it read such that it's a closing statement. Then the next one, 2.4, says there are 13 team participants in a general knowledge competition. What is the probability of correctly predicting the top 4 teams at the end of the competition in the correct order? So here, when order is important, it is the permutation rule. So it would be NPR here. Okay, so that is it for question 2. Are there any questions? All right, so let's move on to question 3 and 4. So this is section B. In section B, remember you are choosing one or the other. You're not going to answer both of them. So section B, question 3 is based on your ungrouped data. Section B, question 4 is based on your grouped data. So you will select whichever you are most comfortable with. I'll give you a general idea of the questions and how to go about answering them, how your marks are allocated. So they say to you for the first one, the following data set indicates the number of radiators sold per week by a local company that sells car spares over a random sample of 11 weeks. Immediately here, n is then equal to 11. So they've given you the 11 values here. Remember, almost always you will be required to rearrange your values in ascending order if they have not already been given to you in ascending order. So generally there is a mark allocated to that if you find that the values are not already in ascending order. But for the purpose of this example, they did have it for you in ascending order already, so you didn't have to worry about doing that. So then the first question asked you to calculate the mean and to interpret your answer. So the mean, remember, is calculated as the sum of all of your values divided by n. So all you're going to do is add these up and divide it by n. Your answer must be 2 decimal places unless they specify otherwise. So once you have your answer, you will interpret it. Remember, the mean is the average. So you'll say the average number of radiators sold, dot, dot, dot. Then the next one is your mode. Remember, your mode is looking at the most frequently occurring number in your data set. So all you have to do is identify the value that's occurring more than once, and you will interpret and say that the most common number of radiators sold, dot, dot, dot. Then the next one is your median. So for your median, generally you do need your values to be arranged in ascending order, which they have done for you here already. So you don't have to do that step. The next one is to determine your position. Remember, you must do those 3 steps generally. So first step is always to rearrange your values if they're not already rearranged. Then the next one is to determine your position. Remember, your position for your median is n plus 1 over 2 when it is ungrouped data. And then the third step is then to actually determine your median or calculate your median. So here, when you're interpreting your value, again, you will say that, remember, your median is basically your middle part or your middle section of your data. It says to you that 50% of the data will be above this value, 50% will be below this value. So you can interpret in either direction, above or below, as long as you're saying half of or 50% of your data. Then you have your third quartile. It's the exact same 3 steps as you see up here. Rearrange, determine the position, but here the position is for your third quartile. It's going to be 3 multiplied by n plus 1 over 4, and then you will calculate your quartile, or you'll determine your quartile. Again, you need to interpret here. Please don't forget about that. Remember, your third quartile tells you, and I'm just drawing up your number line here. So remember, your third quartile is saying to you that 75% of the values lie below this number, and here you can say let's just suppose your third quartile ends up being 24. You will say that 75% or less. That's basically what it's explaining to you. So if the answer is 24, you'll say that 75% of the time, 24 radiators are sold per week. So this is how you would interpret it. There's a mark allocated to saying the 75%. There's a mark allocated to indicating that that was the answer for your 75th percentile. So you can say that 75% of the time or 75% of the customers or the sales were 24 radiators per week. Okay, then the next one is your 60th percentile. So again, here it actually follows the same steps more or less as your median, as your quartiles. And here it is to rearrange, the position is calculated as P multiplied by N plus 1. And then you would calculate your percentile. And here again, by N plus 1, and then you would calculate your percentile. And here again, to interpret, it's the same way as with your third quartile. You'll say that 60% of the time, this is how many, or 60% or less of the, 60% of the time, let's just say we calculated it to be 12, for instance. It would be 60% of the time, 12 radiators or less are sold. Okay, so this is how you would calculate those. Then the next one is your standard deviation. They said to you very importantly here that the relevant formula must be used and no marks will be awarded if the answer is simply obtained directly from the calculator. So to calculate your standard deviation for your ungrouped data, it is the sum of x squared minus n times your mean squared over n minus 1, and it's the root of that. So the variance is without the root, the standard deviation is with the root. So this sum of x squared, this is where you take each of the values here and square it and then sum it up. So basically 25 squared plus 30 squared plus 32 squared and so on. That's your sum of x squared. Then it's minus n. You already know they said to you here. The mean is already calculated in question 1, and it's the mean squared. And then n minus 1 in your denominator would be your n here, which we said was 11 minus the 1. And then it's the square root of that whole fraction. So that's your standard deviation. Then 3.1.7 is what is the coefficient of variation for the data set. This is calculated as your standard deviation, which you already did here, over your mean, which you already did in question 1, and it's multiplied by 100. It must be expressed as a percentage. And then the last one here is to determine the value of the coefficient of skewness using the approximation formula and interpret your answer. So the formula for your coefficient of skewness is 3. It's in your formula sheet as well. It's 3 multiplied by the mean minus the median. And that's over your standard deviation. So once you calculate this value, if you find that the value is exactly 0, then this means that you have a symmetrical distribution. If you find that the value is greater than 1, then this means that you have, sorry, not greater than 1, greater than 0. Then you have a positively skewed data set. If you find that the answer is less than 0, meaning it's negative, then it is a negatively skewed data set. Okay, so that's what they mean by interpret your answer, because if you get, for example, minus 0.25, as long as it's negative and it's below 0, you will state that the data set is negatively skewed. Or if you get an answer like 0.59, it's positive, so you will say that the data set is positively skewed. Okay, so that is question 3.1. Question 3.2 on the next page asked you to draw up a bar chart. So when you're drawing up a bar chart, I will show you how the marks are allocated. So there's a mark allocated to having a title on your x-axis, a title for your y-axis. There's a mark allocated to having a title for the bar chart itself. There's a mark allocated to ensuring that there are spaces between your bars. So here, there's a mark allocated for writing the number on top of the bar, and that's how your 8 marks are allocated. Okay, so please make sure to ensure you have a title, your axes are labeled, there's spaces between the bars, you have the numbers on the bars, and remember your intervals here on your x-axis going across and the values going up. They already gave you the one for your x-axis. The one for your y-axis, you just have to, you can either work in 5, so you can go 5, 10, 15, 20, or you can go in 10, so you can go 10, 20, but it would make more sense for you to work in 5s because the numbers are not so high. Okay, so that is question 3 complete. Let's look at question 4. So question 4 here is based on your grouped data. So question 4 is pretty much the same type of questions that they had asked you with learning unit, sorry, for the question 3, which was your group data. The only difference is that it is now just, sorry, I think I said the opposite thing. Its only difference is that it is now just, sorry, I think I said the opposite thing. It's the same as question 3, but here they're asking you questions based on your grouped data, whereas in question 3, it was based on your ungrouped data. Okay, so here it is, they said to you, the following table indicates the number of customers per week who bought a screen protector from a cell phone accessory store over a random sample of 60 weeks. That 60 weeks is your end value, but they also told that to you in the table. Okay, so here they had asked you, as I said, I think it's identical, the questions, if I'm not mistaken. It was mean, median, third quartile, 60th percentile, standard deviation. Yes, so it's the exact same questions as the ungrouped data that we did here. It's just that it's now for grouped. And here I think they didn't ask you the last two, if I'm not mistaken, just the last one. Okay, so and they didn't ask you the mode as well. So it was a mean, the median, the third quartile, the standard deviation, and the coefficient of variation. So the first one is your mean, and then as I said, mean, third quartile, median, third quartile, standard deviation, coefficient of variation, and your coefficient of skewness. Now, the best advice I can give you is before even starting to answer the questions, you're going to, and this is not for marks, it's just for your own purposes, you're going to redraw this table with what they have given you here, so those two columns, and you're going to add on 4 more columns. The 4 columns you add on will be x, which is your midpoint, fx, then fx squared, and f, which is your cumulative frequency. So I'm not going to do the whole table for you, but I will do just the first one or two so that you have an idea of how to complete it. The first one is your midpoint. So your midpoint is calculated by taking the values in your interval, adding them and dividing by 2. So it'll be, for example, the first one, 0 plus 10, which is 20 divided by 2, and that would be 10. Then 10 plus 20 divided by 2, that's 30. Sorry, the first one was 5. Why am I saying 10? So here 10 plus 20 is 30 divided by 2 is 15. Then 20 plus 30 is 50 divided by 2. That's 25. And then 30 plus 40 divided by 2. 40 plus 50 divided by 2. And you'll continue like that. So that's your midpoints. Then your fx column is literally f, your frequency, times x. So here's your frequency. The number of days is your frequency. I just want to erase here so you can see what I'm doing. Okay, so f times x is literally, here's f, here's x. It's these two multiplied. So 8 times 5 will be 40. 9 times 15. Sorry, let me just calculate that. 9 times 15 is 135. Then 23 times 25, 575. And you'll continue with those as well. Then it is fx squared. So fx squared is f times the x squared. So it's almost the same thing that we did just now, except for the x is squared. So basically for the first one, it's 8 times 5 squared, 9 times 15 squared, 23 times 25 squared, and so on. So 8 times 5 squared is 200. 9 times 15 squared is 2025. 23 times 25 squared is 14,375. And again, you'll continue like that. And your last column is your cumulative frequencies. And your cumulative frequencies, literal to the word, is about summing up each subsequent frequency. So for the first cumulative frequency, it's always the same as the first frequency. Then it is 8 plus the next frequency of 9 to give you 17. 17 plus the next frequency of 23 to give you 40. 40 plus the next one of 11 to give you 51. And then 51 plus the next one of 9 to give you 60. Okay, so that is it for the table. What you're going to do now at the end is you're going to total each column. So this would be the sum of, actually you don't need all of them. So let me just erase which ones you don't need. Okay, so you only need the sum of fx. So you'll say the sum of fx, and you need the sum of fx squared. So this column as well. And you need the sum of fx squared. So this column as well. So the ones that I'm highlighting are the only ones you'll add up. You'll add up 43 plus 135 plus 575. All those added up will give you the sum of fx. Then you'll add up this 200, 2025, that 14375, and those two, and that'll give you the sum of fx squared. So you need that for almost all the questions that you have here. So the first one is the mean, and it's calculated as the sum of fx over n. You already now have the sum of fx from the table, and you have n, so you're just going to take the 2 and divide it. So the sum of fx over n. You know how to interpret now already. I explained that to you just now. Then you have it's interpreted, remember, in the same way as your ungrouped data would be interpreted. Then you have your median. So your median, there is a formula that you'll need to follow. The formula is, I'll write it out for you as well. It is the OME plus, so this is the formula that you're going to use. The C can go here, the C that I put in here, or if you want to, whichever you prefer, you can also not include it here and you can put it on the outside here. So whichever you prefer, they both will give you the same answer. So here the steps that you follow with your median is you will first determine the position of your median, which is n over 2. Then you will determine which interval your median falls into. And then last, you will use that formula and calculate your median. So number 3 is then using that formula at the top. So again, it's interpreted in the same way as well as it had been under your ungrouped starter. You must show all the steps like you have here because again, there are marks allocated to that. Then the next one is your third quartile and interpret your answer. So it's interpreted again in the same way, and it's actually the same steps that you had followed here for your median. So here the position of your third quartile is calculated as 3n over 4. Then you determine your position and then you calculate the formula, and I'm going to show you how similar it is to your median. It's OQ3, then it's 3n over 4 here, then frequency of the group in your denominator. So the formula also is very, very similar to your median. Again, you must show all 3 steps. You must show that this is a position, this is the interval, and then this is how you calculate your quartile using that formula. And then again, you must interpret as well. Then your standard deviation, it is also in your formula sheet. It's very similar to what we did with your ungrouped data. So this is the formula for it. It's the root of the sum of fx squared minus n times your mean squared over n minus 1. This sum of fx squared was already done here. So you actually just need to pull that value from the table once you've calculated it. And you already know it's here. The mean would have already been calculated in question 1. So it's a mean squared and then n minus 1 in your denominator. So the standard deviation is actually quite simple and straightforward. You will have to use the formula again. No calculator method is allowed. And then you have your coefficient of variation. The coefficient of variation is calculated in the same way as we had with your ungrouped data. It's a standard deviation, which was just calculated in the previous question, and then it's over the mean, which would have been calculated in question 1 times 100. So it is expressed as a percentage. And then the last one here is your value of your coefficient of skewness and interpret your answer. Again, it's interpreted in the same way that I had explained to you under your ungrouped data. So it can either be equal to 0, where it's symmetric, where it's a symmetrical distribution, or it can be greater than 0, where it is a positively skewed distribution, or it can be less than 0, where it's a negatively skewed distribution. And then to calculate it, it's the formula of 3 multiplied by your mean minus your median over your standard deviation. Your mean in question 1 was calculated. Your median was calculated in question 2. Your standard deviation calculated in question 4. So you have everything necessary to go into your calculation. So again, if you end up with a value greater than 0, it's a positively skewed data set. Negative value would be a negatively skewed data set, and if it's equal to 0, it's a symmetrical distribution. And then your last one here asked you to, they said the following data set indicates the number of people per day who contacted a roadside organization over a random sample of 20 days. So here n is equal to 20. They said to you, so they gave you all the values and they said construct a group frequency distribution table for this data set. Your table should include columns with descriptive distribution table for this data set. Your table should include columns with descriptive headings indicating the frequency count and the percentage frequency for each class, and the total for each of the latter should be included. Use the classes 20 to less than 25, 25 to less than 30, and so on. So when you draw up this table, you need those 3 columns. You need the, they said to you the number of people who had contacted a roadside assistance organization. So here you can say the intervals or the number of. So you have your frequency, which is the letter F, and then you have your percentage frequency. So they said start with the intervals 20 to less than 25, 25 to less than 30, and you'll continue with them. The frequency would be looking at how many fall into each category. So basically, you're looking at how many people are between 20 and 24. Remember, it says below 25, less than 25. So technically, that means 20 till 24, including 20, including 24. So you'll count from here how many fall into that category. The same here, 25 to less than 30 means 25 till 29, including 25, including 29. And let's just suppose you end up with a value of 10 here and 12 here, for instance, although it's not realistic. Actually, let's just change that. Let's say that this is 10 and this is 5, maybe. Then to calculate your percentage in the last column, it'll be 10 over n times 100. So 10 over 20 times 100 is 50%. The next one will be 5 over 20 times 100, and so on. You'll do the same for the rest of them. Okay, so that's it for your assignment 2 prep. Any questions from anyone? All right, so then that's it from my side. Thank you, everyone. Good luck with your assignment. I will be sending this to your online tutor if you're not in my group, and he or she should send it to you by tomorrow, I'm guessing. Good luck with your assignment, and I will see you again soon. Enjoy the rest of your week. If you are having a long weekend, have a good one, and I will talk to you again soon. Cheers, everyone.